Okay, so we're going to talk about trig identities. Like I said, it's kind of an algebraic approach to trigonometry. So we're going to be solving trig equations, et cetera, et cetera. Okay. Let's look at something you probably can solve. Can you factor that? Yes, what is it? You're close. Okay. X plus 3, x minus 3. That's what we would call an algebraic identity. Okay. Basically what we need is equality for all values. Okay, so it's an equation that balances for all values, right? I've shown you some trig identities. Okay, and we're going to have a lot of these. This is not the only ones, but we can write sine in terms of cosecant, cosine in terms of secant, tangent in terms of cotangent. And then we can also write the ones that are on the board from the warm-up. Okay, so wait, I just did that. I need secant, cosine, those are all identities. Easy to remember because all you need to remember is the sine goes with cosecant, cosine with secant, tangent, cotangent. They're all reciprocals of each other. Okay, that says secant theta equals 1 over cosine theta. It's the same that's on the board. Cosecant is 1 over sine. That's what I get for writing in pen on math class, huh? Nice. And then there's one other. Two others, actually. These we will use a lot. All 8 of them. The tangent is sine over cosine. That comes straight from the unit circle. We're going to use that one a ton. And then cotangent, of course, is the reciprocal of that cosine over sine. So where are we going to use these? Okay, here the first way we can use it, and I think we've already touched on this. If secant is 3 over 2, find cosine. Ideas? Yeah, they're reciprocals. So lots of ways to do this. One, you can just flip it. But I'm going to show you, remember the identity. Secant is 1 over cosine, so plug 3 over 2 in, and then you would flip, take the reciprocal each one to solve. Okay, so 2 over 3. You don't have to make it that complicated. It is easier. I just want to show you where we're headed. So we are headed towards plugging things in and manipulating algebraic trig functions. Okay. All right. There are 3 other identities we need to look at today. They're called the Pythagorean identities. We'll use them quite a bit as well. Okay, here's the first one. This is probably the big one. Sine squared plus cosine squared equals 1. Theta. It's the Greek letter. You can put x in there if you want. Okay. It's just a letter. Variable. Okay, so that kind of looks like the Pythagorean theorem for trigonometry. Here's another one. Tan squared theta plus 1 equals secant squared theta. And then the last one, 1 plus cotangent squared theta is cosecant squared theta. We can use those the same way we did this other one here. Let's try one. If cosecant theta is 4 over 3, find tangent theta. Okay, it gets a little bit more difficult here. This is a chapter where you're going to have to think and problem solve. And sometimes the things that you try will not work. So you erase them and you try something different. You don't just give up. Yeah, I know. But such is life, so suck it up. Okay, is there an identity relating cosine or cosecant and tangent?
No. Yes. Yeah.
Okay, so we can find cosecant and cotangent, right? From cotangent, could we do tangent? Yeah, okay, so let's start here. Okay, and then we'll solve for cotangent and then use another identity to find tangent. So 1 plus cotangent squared is 4 over 3 squared.
just FYI, I don't know if I've mentioned this before. Those are the same thing. It's just prettier to write it with the squared inside. Okay, but it means the same thing, so. You on track with me? So I'm going to subtract 1. That is 16 over 9, right? Yeah. So I'm going to just rewrite it in fractions. And then there's our simplified fraction. Okay, now what do we do? Yeah, square root. We have to get rid of the squared first. Cotangent theta is positive or negative root 7 over 3. Okay, square root of 9 is 3, right? And then root 7 is some funny irrational number that we just don't want to play with right now.
So then you would flip it for 10.
Yeah, now flip it. Okay, now we're in math class. Do we leave roots in the denominator? Nope. We can, but we're not gonna, because it's not pretty. Because we're all about being pretty in here. Okay, multiply by root 7 top and bottom. That was difficult. Okay. Yeah, welcome to it. So basically, we're using some trig identities to do things that we need to do to find values. Just a little bit of an extension on what we did the last couple chapters. Is it? I think so. Okay. All right, last thing I want to show you today. That right there's, yeah. I'll wait for you. Okay. A big part of math beyond calc is producing counterexamples to show things are false. Very useful. So this, let me say, prove this here, sine x cosine x equal tan x is not an identity. So we're showing that's not true by producing a counterexample. Basically, you're looking for an angle measure to plug in there and get some numbers. Okay. Easiest one is 0, right? So if I try 0, Is that true? What's the sign at 0? 0. Cosine is 1 and tangent is 0. Oh, that works. Okay, so that doesn't work. It shows that it works on that example. Any ideas? The other easy angle's 45 degrees, right? Or pi over 4 in terms of radians. You guys, so we're just trying values. You can, my suggestion is 0, 45, and you can go 30 and 60 and 90. All those values are really easy to use. What's the table on like page 305? Just refer to it. What's the sine of 45 degrees? Remember that from the unit circle, anybody? Yay, somebody has it memorized. And cosine? This should be easy now. They're the same. Tangent is 1. Is that true? Okay, so this is not true. We have found our counterexample. In radians, pi over 4 degrees, 45 degrees. Okay, so you're basically just looking for something that shows that it's not true. Capiche? How? Oh, kapow. Nice. We will finish this section tomorrow, but you can start on the work. Pi over 4 is 45 degrees in radians. Ring a bell. Okay, do Friday. I suggest you do as much as you can. Everything I showed you, try to do it tonight. You can bring questions tomorrow. And the advantage of the 2 days per section is that you get time to answer, get questions answered before it's turned in. And I'm going to put a lot more emphasis this semester on you guys doing the review problems. They're going to be a larger chunk of your score. So if you've been doing them, fantastic, no biggie. But they're going to be at least half of your responsibility. So do it. Yeah. Yeah.